Okay, today we're going to talk about two-step equations, and in doing that, let's take a look at some of the examples that we have. These are some basic foundational things we need to know. We just talked about one-step equations where either we subtract, or we add, or we divide, or we multiply, and in one step, bam, we got x equals, don't we? Or we got a number that equals x. All right? Well, these problems, all these problems on the board, they're the same thing, it's just that we do two steps, okay? And we always do the step that involves the letter last, okay? So here's what we're going to do. Watch. We'll take a number or an equation like this. 2x plus 6 is equal to 21. We want to find out what x is, okay? So in order to do that, what we want to do first, all right, is whatever's not x, we got a kind of a positive 6. And remember, we need to get x by itself. So there's two steps to do that, all right? First of all, we got the number. We're not going to mess with the letter first. We're going to take care of this number first, all right? So just like yesterday, all right, the opposite of a positive 6 is a what?
Negative.
A negative 6. So that means we need to provide a number and a sign that obliterates the positive 6 on the left-hand side. Makes it gone, makes it disappear, makes it become nothing. So we're going to write right under it a minus 6, but whatever we do to one side, we have to do to the other, all right? You're going to write minus 6 like that. You're going to write a line, and then you're going to carry everything down in nice, neat, perfect little columns, okay? Yes, that's what we're going to do. So 2x just gets brought down because nothing changed. 2x. Positive 6 and a negative 6. It gets obliterated, it becomes nothing. We don't put a 0 there, we just leave it alone. All right, we carry down our equal sign. Notice how my equal sign is right under my equal sign. What a blessing that is. All right, unlike some of your papers where the equal sign is a mile over to the right, okay? And you don't want that, all right? That's not good little mathematicians. We need to do it sharp, we need to do it right. 21 minus 6, class. 15. Both numbers are opposite signs. We subtract them, we keep the sign of the larger. So we write 15, okay? Now, that's one step. These are called two-step equations, so that means, let's see. We're going to do our second step. What a deal, okay? So 2 and x right next to each other indicate multiplication. What's the opposite of multiplication? Division. So I'm going to divide everything that's not x. Because anything divided by itself is always good. 1. All right, excellent. All right, so we're going to take this, divide it by 2. Take this and divide it by 2. And this x cancels. X equals,
7.
you were right, 7 and 1/2. All right, there's our answer. So 7 1/2 times 2 is 15. And if we add 6 and 15, we get 21, all right? We get 21, so we're good. All right, let's try this next one. Still two-step. It looks like, oh, we got a fraction in there. Don't let that scare you. But before we deal with the a, remember we do it the letter last, so we have to deal with negative 3.6. What obliterates a negative 3.6? A positive 3.6, all right? So let's do it. 3.6, put a nice line underneath it, positive 3.6, and then you're like, Mr. Grace, I'm going to look over there at a decimal problem. It's got multiple signs, and I'm gone. Forget it. I'm going to get the problem wrong. I got a 79% chance of getting it wrong because I'm scared of decimals, okay? Don't do that. It's just an easy problem. It's not a big deal. Don't get scared, okay? Tackle it. Let's bring it all down. A over 1.5, all right, didn't change. This obliterated into nothingness. Bring the equal sign down. Notice I put it right under the equal sign. Not like some of you where it's a mile to the left. Changed it, all right? Let's not do that. This is gone. Look. My sticky note says that these are different signs, so I do what?
Subtract.
I subtract and I keep the sign of the larger number. Would you rather have $4.40 or $3.60? Yeah, so 4.4 is larger, so we know that our answer is going to be negative. I'm going to write it there, okay? 4.4 minus 3.6. We have to keep our decimals lined up because it's an addition problem for decimals. 4 minus 6 we can't do, we have to borrow, don't we, okay? Back into elementary school. This 4 becomes
3, 0.
3, okay? So 3, we got that 4. 14 minus 6 is 8. 3 minus 3 is nothing. Put our decimal here, okay? A negative 0.8, all right? And that's our answer. Okay? They say, Mr. Graves, but when you do it on the board and we just, it's all good and everything, but when I do it on my homework, it doesn't work. Okay, that's all right, but that's why we practice. That's why we do homework. That's why you take the principles of what's being taught and you apply them starting with the very first problem on your homework. All right? 2 steps. It's not a problem. We do the letter, whatever's the letter, we associate it with it last. Okay? I gotta keep rolling. All right, here we go. X over 3.
You have another step on.
Oh yeah, I'm sorry. Thank you. Okay, equals negative 0.8. Let's take that over here. All right, thanks. So rudely interrupted. Okay. All right, equals negative 0.8. All right, now what we have to do here. This is a division. What's the opposite of division? Multiplication. We're going to multiply both sides by the denominator. So what do we multiply both sides by? 1.5. 1.5 over 1. Okay? And I write it as a fraction. You don't necessarily have to do that, but in this particular case, it's okay. All right? And we're going to multiply 1.5 over 1. We'll put these in parentheses. Okay? And I think we're good, which really is a negative 0.8 times 1.5. So 1.5s here cancel. You know how it cancels 10 times out of 10 when I multiply that by the denominator? Because that's what happens. 1.5, 1.5. What am I left with?
8.
A equals, okay? What's a negative times a positive? Negative. So let's just put our sign there so we don't get it wrong, okay? Let's do it, all right? 1.5 times 0.8, all right? Which has more digits, 0.8 or 1.5? 1.5. Well, why don't we put that one on the top, okay? 1.5 times 0.8, okay? 8 times 5 is right around 40. 8 times 1 is 8. 8 plus 4 is 12. All right? Excuse me. We have 2 decimal spots. So we start from the right and we move over 2 and we get 1.2. So our answer is not a positive 1.2 like some of you might write. Negative 1.2. All right? Now watch. Let's move and go quicker here. All right? Letter we deal with last. 2 steps. What obliterates a negative 7? Positive 7, all right? I'm going to write that down, put my line. X over 3 gets carried down, obliterated, equal sign. 2 plus 7 is 9, all right? Opposite of division is? Multiplication. You're going to multiply both sides times 3 over 1, or 3. All right? The 3's cancel, x is equal to 27. Easy enough, all right? Now, here's what we're doing. In these kinds of 2-step equations, we're going to obliterate the number that's not associated with the letter first. If it's a negative anything, then we're going to do a plus whatever it is. And then we're going to just add on the other side. And whether it's a decimal or a fraction, you're just going to conclude whether you're adding or subtracting different signs. And you would just treat it as a normal fraction problem or a normal whatever it might be, okay? There's lots of examples, and of course you'll do some in your homework and I'll help you. Many of these fractions, you can make them totally just obliterate the denominator by multiplying both sides by the denominator, okay? And then of course, anytime you've got numbers next to each other, like 3x is equal to 15 and you've got multiplication, you obliterate the number next to the letter by dividing by whatever is not the letter, 3. And that cancels, and the other side would be by 3, okay?